Do you hear the nature sounds? That's because today we are going to be live streaming outside. I'm streaming off of the hotspot on my phone, which I did not think about what would it be like connection wise. But yeah, we're going to be reading about the water cycle. Yeah, from the United States Geological Survey. Um, I typically just want to read from websites, unless it's like Wikipedia or some shit. But and I can read a .com here and there. But like typically, I want to read from websites that have an edu or a gov. I'm gonna be honest. Like those are kind of like my only. Those are my only like classifications. I don't want to say trust per se, because you also still have to read the information, but I feel more reliable with. With that being said, let's read about the water cycle. The water cycle describes where water is on Earth and how it moves. Human water use, land use, and climate change all impact the water cycle. By understanding these impacts, we can work toward using water sustainably. What is the water cycle? This intro though. Human water use, land use, and climate change all impact the water cycle. I'm very interested on how human water use is recycled back into the planet. I'm gonna be honest. Is it through our pee? It's most likely through our pee. Maybe like sweat. Yeah, whatever happens to like sweat and stuff. Anyways, okay. By understanding this, we can church using water sustainably. What is the water cycle? The water cycle describes where water is on Earth and how it moves. Water is stored in the atmosphere, on the land surface, and below the ground. It can be a liquid, a solid, or a gas. Liquid water can be fresh or saline. Saline? That's how you say it, right? Like salt. Yeah, saline is salty water. Water moves between the places it is stored. Water moves at large scales through watersheds, the atmosphere, and below the Earth's surface. Water moves at very small scales too. It is in us, plants, and other organisms. Human activities impact the water cycle, affecting where water is stored, how it moves, and how clean it is. Pools store water. Thanks. Human activities impact the water. Yeah, but how do we piss out the water and it goes back into the water cycle fresh? Anyways, pools store water. Oceans store 90%, 96% of all the water on Earth. Ocean water is saline, meaning it's salty. On land, saline water is stored in saline lakes. The rest of the water on Earth is fresh water. Fresh water is stored in liquid form. Freshwater lakes, artificial reservoirs, rivers, and wetlands. Water is stored in solid, frozen form in ice sheets and glaciers and snowpack at high elevations or near Earth's poles. Water vapor is a gas and is stored as atmospheric moisture over the ocean and land. In the soil, frozen water is stored as permafrost and liquid water is stored as soil moisture. Deeper below ground, liquid water is stored as groundwater in aquifers. Aquifers? Water in groundwater aquifers is found within cracks and pores in the rock. And we got an image here of fucking Earth. Viewed from space, the most striking feature of our planet is the water. In both liquid and frozen form, it covers 75% of the Earth's surface. It fills the sky with clouds. Water is practically everywhere on Earth, from inside the planet's rocky crust to inside the cells of the human body. What's important to keep in mind is that all of the water is in constant motion across our planet. Moves water between pools. Fluxes move water between pools. So this is where all the places that water becomes stored. Now we're about to get into like how it maneuvers. As it moves, water can change form between liquid, solid, and gas. Circulation mixes water in the oceans and transports water vapor in the atmosphere. Water moves between the atmosphere and the surface through evaporation, evapotranspiration, and precipitation. Water moves across the surface through snowmelt, runoff, and stream flow. Water moves into the ground through infiltration and groundwater recharge. Underground, groundwater flows within aquifers. Groundwater can return to the surface through natural discharge into rivers, the ocean, and from springs. What drives the water cycle? Or I should say, clouds are formed by water condensing in the atmosphere. When the water is released back into the Earth's surface, we experience precipitation. Both condensation and precipitation are important fluxes in our water cycle. What drives the water cycle, though? What's pushing it? Water moves naturally and because of human actions. Energy from the sun and the force of gravity drive the continual movement of water between pools. The sun's energy causes liquid water to evaporate into water vapor. Sorry, I'm getting distracted by humans. Um, evapo. Okay, I'm gonna read that all again. What drives the water cycle? Water moves naturally and because of human actions. Energy from the sun and the force of gravity drive the continual movement of water between pools. The sun's energy causes liquid water to evaporate into water vapor. Evapotranspiration is the main way water moves into the atmosphere from the land surface and oceans. Gravity causes water to flow downward on land, causes rain, snow, and hail to fall from clouds. In addition to natural processes, humans alter the water cycle. In addition to natural processes, human water human water use affects where water is stored and how water moves. We redirect rivers. We build dams to store water. We drain water from wetlands for development. We use water from rivers, lakes, reservoirs, and groundwater aquifers. We use that water to supply our homes and communities. We use it for agricultural irrigation and grazing livestock. We use it in industrial activities like thermoelectric power generation, mining, and aquaculture. Um, we also affect water quality. In agricultural and urban areas, irrigation and precipitation wash fertilizers and pesticides into rivers and groundwater. Power plants and factories return heated and contaminated water to rivers. Runoff carries chemicals, sediment, and sewage into rivers and lakes. Downstream from these sources, contaminated water can cause harmful al- algae, algal blooms, like algal, algal blooms, spread diseases, and harm habitats for wildlife. A reservoir is a human made lake. Reservoirs form when a dam is built on a river, allowing water to pool behind the dam. The water cycle and climate change. But there no pissing? No pissing though? I guess that's waste. But like, how does the waste? No pissing? Wait, I'm so surprised they didn't bring up pissing. I mean, the water we use to supply our homes and communities. It that water goes inside my body or onto my body, which would seep into my body, which would then come out as piss. Am I crazy? And then what happens with the piss? Okay, sorry. The water cycle and climate change. How many? 1, 2, 3, 4, 5, 6. Four. Climate change is actively affecting the water cycle. It is impacting water quantity and timing. Precipitation patterns are changing. The frequency, intensity, and length of extreme weather events like floods or droughts are also changing. Ocean sea levels are rising, leading to coastal flooding. Climate change is also impacting water quality. It is causing ocean acidification, which damages the cells and skeletons of many marine organisms. Climate change increases the likelihood and intensity of wildfires, which introduces unwanted pollutants from soot and ash into nearby lakes and streams. What determines water availability? Humans and other organisms rely on water for life. The amount of water that is available depends on how much water there is in each pool. What about our piss pool? Is that counted in the water cycle? Water availability also depends on when and how fast water moves, water timing through the water cycle. Finally, water availability depends on how clean the water is, water quality. By understanding the human impact on the water cycle, we can work toward using water sustainably. Now, I have a really cool thing to show, actually. Um, this is a interactive water diagram. It says it's for kids, but this is so fucking cool, just as like a general diagram. I'm gonna show you guys just in a bit. Hold on. Let me zoom out. And then we'll change screen and let's share screen again. Let me show you guys this. Check this shit out. Check this shit out, guys. The interactive water cycle diagram is being updated. Oh, wait, that's not what I wanted to read first. The water cycle describes how Earth's water is not only always changing forms between liquid, solid, and gas, but also moving on, above, and in the Earth. The process is always happening everywhere. You may think that every drop of rain that falls from the sky or each glass of water that you drink is brand new, but it has always been there and is part of the water cycle. Okay, so that confirms that piss is a part of the water cycle. But there's no piss. Piss isn't one of the. Okay, let's just go. Let's start from top to bottom. Ice clouds, ice in the sky. The clouds overhead are made of water, and of course, most of the clouds you see in the atmosphere are composed of tiny droplets of liquid water. But not all. Very high in the sky, the air gets really cold, way below freezing. Clouds in this region are made of ice particles. You see ice clouds all the time as cirrus clouds. They are usually rushing by as they are late for dinner, but that is only because the winds at high altitudes are often moving very fast. Actually, some of the cirrus clouds. Actually, some of the cirrus clouds you see are created by humans. These are the contrails, uh, or condensation trails made by airplanes, as you see in this picture. And then there's okay, we'll do normal clouds. How much does a cloud weigh? Clouds are made of water, and water has weight. So how can they float? They float because the air below them has weight. Uh, two, it has weight. Two, wait, what is the sentence? Is that a comma? They float because the air below them has weight. Two, more weight. Like, what? Okay, whatever. Is that a, that is a fucking comma. Okay, think about oil and water. If you pour oil into water, the oil floats to the top of the water. That is because oil is lighter, less dense than water. Same thing that applies to clouds, and same thing applies to clouds in the sky. What what fools you is that water vapor in the air in the air in a clear blue sky is invisible. Um and there is not enough water vapor to condense into clouds. Water vapor contains water molecules, one oxygen atom and two hydrogens. You know hydrogen is the lightest of all elements. Shit, I'm sorry. I'm getting distracted by fucking hot women. You know hydrogen is the lightest of all elements, even when combined with an oxygen atom. The hydrogen acts. Oh, it's fine. Okay. Sorry, I totally just fucked that up. The hydrogen acts like little hot air balloons that make the vapor lighter than the molecules in the surrounding dry air. Water vapor naturally floats upwards, eventually condensing and forming clouds. And a cloud weighs, according to NOAA, I don't know what the National Observatory of something of atmospheric something. The National Observatory of Atmospheric something. Why? Okay. NOAA. The National Oceanic and Atmospheric Administration. That's what it is. I knew it was national and atmospheric. I knew it was going to be those two, but Oceanic and Administration. I see. According to the National Oceanic and Atmospheric Administration, your average cumulus cloud, uh, cloud, your average cumulus cloud, 1 kilometer on a side, will weigh about 998 million kilograms, 2.2 billion pounds, as equal to about 22 million kids weighing 100 pounds each. Wait, why are clouds so fucking heavy? Holy shit, I didn't know clouds got heavy. I mean but that kind of makes sense though, I guess. Like a cloud will 0.62 miles. That's not even that fucking long. And I mean, because it's, well, I guess because water droplets are so light and because they're becoming so dense, like it's such a small point. And of course, it's going to weigh that amount because it's such a dense point. Clouds, then we'll do sun and atmosphere, and then you guys can check out the rest of I don't want to keep running up my data, I'm going to be honest. The sun. Who's the boss? Okay, I see why it's for kids now. The real boss of the water cycle doesn't even live here on Earth. The sun is what makes this water cycle work. The sun provides what almost everything on Earth needs to go: energy or heat. The sun is so big that even at over 90 million miles, you can feel its heat. The sun's energy affects water at its smallest level, the molecular level. Liquid water contains water molecules stuck together. The energy from the sun can break apart these tightly held molecules into much smaller sets of water molecules, which result in tiny water vapor particles, an invisible gas. This process allows liquid water to evaporate into water vapor, which in the main way water gets from the land surface and oceans back into the sky. The sun also participates in moving water around the earth. Different parts of the world, and even your neighborhood, are heated to different levels by the sun, and unequal heating and cooling parts of the landscape causes air to move around from here to there. The winds. You know that the wind moves clouds and the weather all you know that the wet winds move clouds and the weather all over the place. All of this mixing up and moving is an important part of the water cycle. Levels by this. It's like little air pockets siphoning into cooler places because heated places are more like they're densely packed within. I'm guessing, kind of, or like at least they become more excited, so they're taking up more space. There's not enough room to actually when it's being heated, it's actually expanding outwards. It's pushing um more molecules or more stuff out. Whereas, yeah, as it becomes cooler, that's because it's leaving a void for um, molecules or stuff to flow into. All right. And now the atmosphere. The atmosphere truly is the superhighway in the sky that moves water everywhere over the earth. The next time you go outside, you will be standing in the Earth's atmosphere. The atmosphere is all the air from the bottom of an ant's leg up to where there is no more air, many miles in the sky. The air outside may look invisible, but it is full of molecules, including water molecules, as water vapor. That big cumulus cloud full of water floating in the sky is the water cycle in action. I actually don't see any clouds in the sky currently today. I wonder if it's because earlier there was a big storm earlier this morning, so maybe just like maybe all of the maybe they're all down here. I mean, technically they're all down here, and the sun heating is heating them up to break them down into lighter water vapor right now. And so, like, water vapor, I'm currently existing within a realm of rising water vapor, which is so cool. The water vapor, the water vapor, the water vapor, the water is a vampire essentially. The water vapor all around you rises up into the sky to become part of a cloud which will float off with the winds, probably looking for a picnic to rain on. A cloud in the atmosphere can move from hundreds of miles before it releases its water as rain or snow. That is how water that evaporates from the ocean one day may end up as rainfall over Esmeralda's tomato patch in Kansas the next day. Because it's like it's being blown in a vertical sense, and it's rising in a vertical sense, and it's radically being propelled. Is the water that could be a really interesting question. Okay, so we've confirmed that peeing is a part of the water cycle, but what I'm interested in is the water rising faster than it's horizontally moving? Is water moving horizontally faster than vertically? Water generally moves faster horizontally than vertically in both oceans and groundwater systems. Horizontal surface ocean currents and river flows are often wind-driven and gravity-driven, resulting in high speeds, while vertical movements like ocean upwelling are typically very slow, moving only a few meters per month. is water, I should specify in the water cycle. Yes, water in the water cycle generally moves horizontally much faster than it moves vertically, particularly when comparing horizontal atmospheric transport or river flow to the slow vertical movement of groundwater or deep ocean circulation. While evaporation upward and precipitation downward are fast vertical processes, the overall net transport of water across the planet occurs horizontally over much greater distances in much less time. Oh, damn. That's crazy, dude. Evaporation, precipitation. Just so I understand precipitation a little better. In meteorology, precipitation is any product of the condensation of atmospheric water vapor that falls from clouds due to gravitational pull. Okay. Include drizzle, snow, ice pellets, graupel, and hail. Surface of the earth. Well, that was kind of a fun read. That was really fun. Um, yeah, shout out the oh my god. Shout out the United States Geological Survey, and also shout out the National Oceanic and Atmospheric Administration for educating people about the most potent cycle on our planet that we inhabit, the water cycle. And remember, next time that when you're taking a piss, you are contributing to the cycle of water. I love you. I love our journey of information. And you have a great day.